Hey again, everybody. This is going to be another example for surface area. We're going to do the last example on the notes page, which was an object that seemed to have multiple figures connected. So we do need to find the surface area of this. And the easiest way to think of it, honestly, is if you had to like wrap this, like in wrapping paper, what would really be covered when you wrap it, right? You'd have to wrap around here, and you'd have to wrap around the top part, and you'd have to wrap the bottom as well, right? So what that means is you're not actually wrapping like this part right here because it's like on the inside. So what usually happens is when people do a surface area problem like this, they just say, oh, I see a cylinder, I see a cone, I'm going to do the formula for cylinder, I'm going to do the formula for cone, I'm going to put them together, and you feel pretty good. Unfortunately, it's not quite that simple. So I'm just quickly copying it down underneath here, and then we'll do it together. Okay, so let's see. So here's the picture essentially. And again, if I were wrapping paper around this, I'd have to wrap around the cylinder, around the bottom of the cylinder, and then around the curvy part of the cone. Not the circle part, just sort of the lateral area. Okay? So when I go to do, let's do the cone first. When I go to do my formula for surface area of the cone, of course I start like this, plus 1/2 PL, which turns into this, plus pi RL, like we talked about in the other video. But then I quickly realized, wait a second, I'm not actually using that. Right? That would be right here. That would be this for the cone. That would be this part. But that part's inside. That's covered. Not covered, but it's like, it's being, I don't know. I guess it is not showing is the better way to put it. Okay? This part right here is not showing. That is not a part that needs to be wrapped. Okay? It's already like inside. So I'm not going to use that. I'm just using this part, which just covers the lateral surface area, just the ice cream cone part, not where the ice cream would go, if that makes any sense. That doesn't make sense either, because ice cream does go inside the cone. So just the cone itself. Pretend there's no ice cream at all. Okay? So this, of course, is going to be pi times the radius, which, of course, is 6. Right? That would be the same radius up here, which is 6, times the slant height, which they were nice enough to give us. And that takes care of the surface area of the top part, which is 60 pi, which, you know, is whatever. Oh, 60. Wow. I believe I forgot to. Oh, no, that's right. I'm sorry. That's 60. Sorry, my eye wandered to the wrong part of the page. 60 pi is approximately 188.5. Okay? So that takes care of, that is this part. Now I need to do the cylinder. Well, the cylinder from the other, you know, the section we were doing, we remembered is 2 big B plus pH. But since it's a cylinder, we know big B, of course, is a circle. So that's 2 pi r squared. Perimeter of the circle is really the circumference in disguise. That's 2 pi r times the height of the cylinder. But again, I am not dealing with the one of the big B's. Okay? I have 2 big B's for the cylinder. If you just focus your eyes on the cylinder, these are your bases. But I'm not using this one. So instead of 2b, or 2 pi r squared, it's just 1 pi r squared. Okay? So that's pi 6 squared plus 2 pi times 6 times the height of the cylinder, which is 8. And that's going to get us about 414.7. And then I put these two things together. I've got the surface area of the cylinder that I can see, the surface area of the cone that I can see. I put those two guys together, and when I add them up, I get about 603.2 square inches. Okay, so this is probably the trickiest that we're going to have to deal with, at least for a while, because, again, recognizing that this particular circle that would normally be part of the cone, right, if I were to separate them, here, let me do that. If I were to separate them and just say, find me the total surface area, find me the total surface area of those two things, then you'd have to literally do each one by itself, you know, the original formula with the original formula, and add them together. But as soon as I put this guy on top, and he literally is now blocking the circle that was here and the circle that was on top of the cylinder, then all I'm really dealing with is the lateral surface area of the cone, the lateral surface area of the cylinder, and then the bottom of the cylinder. And I would not actually be not counted, not using the circle that's in between. Okay, so hopefully that helped a little bit. That's the best I can do, I think, for now. But if you still have questions, of course, just ask, and I'll try to clarify as best I can. Okay, all right. Talk to you soon. Bye.